So all these solutions that we've done, you had one answer. X was 2 on these problems, meaning the only number that I could put in up here and multiply it by -12 and get -24 was +2. It's the only thing that worked. One solution. What's the only number that I could put in for X, multiply it by 20 and get 80? 4. One solution. What's the only number? You get the point, right? Okay. So that's about to change. You are going to see something that you've not seen yet, I don't think. I don't think this is part of the 7th grade curriculum, so just kind of watch this. Special cases, we call them. Special cases is when something out of the ordinary happens. So I need everybody looking up here, making sure you're listening, because this is important, okay? Yeah, so you can turn it, yeah. So if I have an equation that says 3x equals 3 times x plus 4. You might not think anything of it right now. Your instinct tells you to distribute a 3, and that would be right. And so you would say, nothing over here. Sometimes there's just not a constant there. 3x plus 12. If you're kind of aware of things, you might know something weird's going on right now just by looking at that. Because last I checked, 3x should equal 3x. Not 3x equaling 3x and then plus 12 more. Let's keep going. Alright? So when I go to get my variables all on the same side, I want them gone from here. What ends up happening? They cancel on both sides. And I don't know if we've had that happen yet before we get to algebra, but it's funny because when something weird happens, a lot of kids just kind of freak out and they're like, not possible. They just write not possible. It's funny. It's kind of like the first time that, somebody has this happen. 4x equals 11. And they go, not possible. Like, oh, it's not a whole number, but it's possible. You're just not going to have a whole number. So people automatically start losing their minds when stuff like this happens. Now, hold on. I want you to write this right here. When both, this is so important. It's going to pop up all throughout the year, so learn it now. When both variables end up canceling out, don't lose your mind and put not possible. One of two things is going to happen. But it requires some further investigation. So after this canceled over here and there's nothing left, what number represents nothing? Because you still need your equal sign. You need to make that 0. And after this canceled, what's still left on the right? 12. And you don't have to be a rocket scientist to figure out that that's not true. 0 does not equal 12. In no world does 0 equal 12. So what kind of statement do we call that? True or false? False. Now, stop here, because the whole purpose of solving equations is what's the solution? What's the solution? Does false answer what's the solution? No. So the word false is going to lead me to what I actually write. But I'm not going to tell you what it is yet, because I'm going to ask you to try your hardest to give me a value of x that I could put in for here and here and make it so it would work. Somebody give me your favorite number. 7. That was somebody in third order favorite number. 3 times 7 is 21. 3 times 7 is 21. Oh, now add 12 to that. Okay, that doesn't work. Somebody else give me their favorite number. Probably. 3. That was the second number somebody chose in third hour. That is really strange. 3 times 3 is 9. Plus 3 times 3, which is 9. Oh yeah, now add 12. We're going to be here a long time trying to find a number that I can put in here and here and have it work. So guess what? What's the answer? 0. What's 0 times 3? 0. What's 0 times 3? Plus 12. Doesn't work. Because guess what? There is not a number on the face of this earth that is going to be able to work when I plug it in. So yes, that is no solution. There's no, I'm talking and writing. There's no solution. Solution. No solution. Because just like, I'm looking on this other one. Hey, 4 worked here. 2 worked here. Nothing's going to work for X. That's what no solution means. Try as hard as you want. You're never going to come up with a number that you can put there. Because 3 times a number will never equal 3 times a number plus 12 more. Got it? Okay? So that is called no solution. So can you guess what example I'm going to do next? Because what's the opposite of nothing working? So let's see what type of an equation results in that. 2x plus 10 is equal to 2 times 5 plus x. So I distribute my 2. I have 10 plus 2x. I know what you're thinking. That doesn't look the same. But what mathematical property says that it is the same? When the order doesn't matter, it's called the commutative property. So I know that 10 plus 2x and 2x plus 10 are the same, right? So for some people, that's enough. They stop right there. But watch. Some people kind of want to see it through. So they're like, no, I want to get rid of this. I want to, not that. I want to cancel out this. But when it cancels here, it also cancels here. But what am I left with this time? 10 equaling 10, which is what? True. So does 10 equal 10? Yep. We put a little check mark. We said that checks. So if a false statement means nothing works, then a true statement is the opposite of nothing working, which means every number would work. Let's try Chris's favorite number, 7. What's 2 times 7? Plus 10. 24. What's 2 times 7? Plus 10. 24. If we try 3, if we try 1,000,000, if we try 0.762, if we try 0, every single number will make it work. So there's 3 ways to say that. I want you to know all 3 ways because some tests say all real numbers. This is the one I like. All real numbers just means every single number on the planet that you could think of that's a real number will work. Another way to say that is infinitely many. I don't really kind of like that word because many just makes you think of the word a lot. And the amount of numbers that work in here is more than a lot, but the word infinitely, I guess, makes up for that. So all real numbers, infinitely many. Your book is going to use this phrase or word. I don't really like it, but I get it. They're going to say identity. It's because this is the exact identity as this. Like if this were a mirror, this would look in the mirror and see itself, even though it's reversed. Okay? But I kind of like, what's your solution? Oh, all real numbers would be your solution. Infinitely many numbers could be your solution. Identity. It just doesn't go for me. Okay? So, how many possible solution types could there be for an equation? You could have an equation that has one solution. You could have an equation that has none. And you could have an equation that has infinitely many. Those are your 3 types of solutions for equations. Got it? Okay. Those are your special cases. All right.